But there is more. Yeah, there's more. We're doing good though. We got some good drawings. Let's continue this idea of drawing some models to now model this idea that we call the greenhouse effect. So now we're going to tie all of this together, the fact that we have an atmosphere, the fact that it's made out of certain gases, and the fact that energy from the sun heats up our Earth and our Earth emits infrared radiation. This is what then forms this idea that we call the greenhouse effect. All right, the greenhouse effect. If you've ever been in a greenhouse, especially like in the spring, it's usually warmer than it is outside in the greenhouse. In the summer, it's just almost too hot to handle if you're in a greenhouse. So let's take that idea and describe the greenhouse effect. So some of the gases in our atmosphere, not all of them, but some gases in our atmosphere actually absorb and reflect infrared radiation. Remember that heat that's leaving the Earth after the sun heats it up? Yeah, some of the gases in our atmosphere absorb and reflect that heat. And it absorbs and reflects it back to Earth's surface. Well, would you look at that? You know what we call those things? Those gases that reflect it? We call these greenhouse gases. So let's say these gases equal or are called greenhouse gases. All right, so let's define what the greenhouse gases are, or at least our most common ones. So greenhouse, let's say common greenhouse gases on Earth. Because you can have the greenhouse effect. They have the greenhouse effect over there on Venus, and they have a very different composition of greenhouse gases. But on Earth, our greenhouse gases are made up of primarily carbon dioxide, which is why we hear about carbon dioxide in the news a lot. And when we talk about climate change, carbon dioxide is really, really important there because it is our most abundant greenhouse gas. Our second most is methane, nitrous oxides, and even fluorine gases, or fluorinated gases with fluorine on them. So if we were to write the chemical formula of each of these, again, remember carbon dioxide is CO2, methane, CH4, nitrous oxide is N2O. Fluorinated gases are fluorine on a gas, so we'll put F with an X there because it could be fluorine on any other type of gas. All right, so if we think about the percent of the greenhouse effect that each of these account for, percent of, and let's just abbreviate by putting GH effect. So the percent of the greenhouse effect that carbon dioxide plays a role in is 81%. So 81% of the heat that stays on Earth, the reason it stays here is because of carbon dioxide. 10% of the greenhouse effect is impacted by methane, about 6% is impacted by nitrous oxide, and that leaves about 3% for fluorinated gases. Now there are some other greenhouse gases, but these are the ones that are the most measurable. But wait, this does not mean, let me say it again, this does not mean that 81% of our atmosphere is carbon dioxide. Let's flip back a page. Don't you remember? Only 0.1% of our atmosphere contains many gases, and one of them is carbon dioxide and methane. So when we say that carbon dioxide is 81%, we mean that of that 0.1%, 81% of that gas is carbon dioxide. 10% is methane. Yet these gases are constantly talked about in the news, which just shows how much they actually warm our Earth. The smallest amount can have a big effect. All right, let's make a final diagram about what we've learned here. So if we were to draw the curvature of the Earth again, we know that there is different layers in the atmosphere, but I'm just going to draw one of those because most of the greenhouse gases are going to be found down here in the troposphere. So let's include let's draw some circles here of areas that would represent the greenhouse gases. So let's say we have some methane. I'm just going to draw a circle around it just to contain it. It doesn't mean all the methane is right there. But if we have methane, carbon dioxide, fluorinated gases, nitrous oxide, even water vapor is actually a greenhouse gas, but we don't count for it here because the amount of water vapor in the atmosphere is constantly changing. So if I draw a cloud, that means that there's a lot of water vapor in that because we can see it. There's also a lot of water vapor that just hangs out in the air when we can't see it. That's what we call humidity. But don't forget, there's other gases in the atmosphere. We also have things like nitrogen, and we also have argon, we also have oxygen. So let's show what would happen if we have our Earth, which has a little lump kind of weird over here, but let's say that our Earth then is radiating that infrared radiation. That infrared radiation is going to hit the methane and be absorbed. The methane might jiggle a little bit, and then it's going to reflect that energy back to the Earth's surface. So that's infrared radiation. Or infrared radiation is going to hit carbon dioxide. It's going to cause it to vibrate a bit. It's then going to be returned back to Earth's surface. That's infrared radiation. Infrared radiation could also go up and hit the fluorinated gases. It's going to vibrate a little bit, and it's going to transport that energy. It's going to reflect it and absorb it back to Earth's surface. Again, that was infrared radiation. Infrared radiation could also hit nitrous oxides. You're right. It's going to cause it to jiggle a little bit, do a little dance in the atmosphere. It's going to return that energy back to Earth. You can see a pattern. These are all greenhouse gases returning that energy back to Earth. Now, if you've ever noticed on a nice cloudy night, it doesn't get that cold because Earth's energy, the infrared radiation, leaves the Earth, hits the cloud, and it actually is absorbed and reflected by the cloud back to Earth. Yeah, it's absorbed by the cloud. So when clouds come over our head, they're literally transfer energy down to the Earth's land. Crazy. Crazy. Now, water molecules in the air do the same thing. They have the ability to be a greenhouse gas as well, and they're going to transport that infrared radiation back on down. But look at this. We're now in the realm of non-greenhouse gases. So predict, what do you think is going to happen? The infrared radiation hits nitrogen, or it hits argon, or the infrared radiation hits oxygen. Well, guess what? Those gases don't care, and the infrared radiation just keeps on traveling further and further away from the Earth. So it does not reflect it back down. So if we add more oxygen, more argon, more nitrogen to our atmosphere, we're not going to see a warming effect. But if we add some of these other gases to our atmosphere, then we're going to notice a warming effect because they're greenhouse gases. They trap the infrared radiation by absorbing and reflecting it back to Earth. So let's summarize and say that without the greenhouse gases, our Earth would be too hot or too cold. Too hot during the day, and too cold, you guessed it, during night because the sun's not shining on it. It'd be too hot because the sun's shining on it, and too much of the sun's energy would get through and immediately heat the Earth. But these do provide some blocking as well when the sun's energy comes in. When it does come in, though, and heats the Earth goes and heats these molecules, and they then, in turn, heat our Earth. So without the greenhouse gases, our Earth would be too hot or too cold to sustain life. And that, ladies and gentlemen, would not be good for any of us. That's why a lot of scientists say that the Earth is in the Goldilocks zone. We're in a zone that is not too hot and not too cold to sustain life. So therefore, we live within the Goldilocks zone in terms of being a certain distance away from the sun. Yet we're also a Goldilocks planet because we have these greenhouse gases that don't make it too hot, don't make it too cold. We're right there in a nice, sweet spot in the middle. That's all we have for right now, and as you guys dig deeper into this unit, you're going to figure out what happens if we add more gases up here into our atmosphere. You might already know, but let's do some testing. Yo, I'm out. See ya.